Let's go to page 377. This is lesson 8-6, and the objective of this lesson is to solve a polynomial equation with a real coefficient. Okay, so over here, first you need to know the degrees of a polynomial equation. The degree of a polynomial equation is the exponent of a highest term. Okay, so over here, so this is the first degree, so you're going to get one answer. Okay, and over here, notice the highest degree. So this is degree 2. The highest degree is 2, so you're going to get 2 answers. This one is degree 3, so you're going to get 3 answers, and so forth and so forth. So this is a 4th degree equation, so you're going to get 4 answers. This one, the 5th degree, the 5 power. These are your answers, and you're going to get 5 answers. Okay, so the theorem says that the polynomial with an n degree has n number of roots. So if it's first degree, you're going to get 1 answer. 2 degree equation, you can get 2 answers. 3 degree equation, get 3 answers, and so forth. Okay, so that's what this theorem is saying. Okay. Now let's go to example 1. Okay, example 1. It says find a cube equation with an integral. Integral means integer. So integral coefficient that has 2 and 3 minus I as roots. Okay. Now again, it asks you for integral coefficients. Okay, and notice there's an I. So this is not an integer. So to get rid of the I, you need to have a conjugate. So right away, so the 3 roots would be 3 minus I and 3 plus I. Again, you need to have a conjugate to get rid of the I in order to get the integer coefficients. Okay. Okay, so now once you get your roots, you need to go and get your equation. Okay. And normally you would do this. This would came from x minus 2. This would become x minus 3 minus I times x minus 3 plus I equal to 0. So this is going to be messy to multiply. Okay. So instead of doing this, what I'm going to do is instead of doing this and multiply in a mess, so what you want to do, you want to use the root equations. Okay. So what I'm going to do is, for example 1, I'm going to make R1 equal to 3 minus I, R2 equal to 3 plus I. Get a conjugate. And the R3, I'm going to put it off on the side, okay, for now. So I'm not going to worry about this for now. So I'm going to focus on this part. Okay, I'm going to use the conjugate roots to get my depressed equation. So write your equation. Remember your root equation. This is from your chapter 7. Okay. So if you don't remember, you need to go back and review that a little bit. Okay, so that is from, so this is from your page 338. Okay, so go back and review if you don't remember. Okay, so now you go and just work it out. Okay, so this one, when you add, this will cancel out. So 3 plus 3 will give you 6. Right? Again, when you add, this will cancel out. So that's kind of nice. Right? So again, plus and minus will cancel out. So you're going to get 6. Now, multiply. When you have conjugate, when you multiply, you just multiply the corresponding part. So 3 times 3 will give you 9. Negative times positive will give you minus. I times I is minus 1. So and it's already have negative, so it become plus 1. So from these 2 roots, you're going to get x squared minus 6x plus 10 equal to 0. Okay? So these 2 answers came from here. Now you're going to include these. Well, from here, you're going to get, from this part, you're going to get x minus 2 equal to 0. Right? So this came from this. So now you're just working backward. You're going to put these 2 together. Okay, I'm going to put this in the front. So it'll be x minus 2 times x squared minus 6x plus 10 equal to 0. Okay? Then I'm going to distribute. Again, use your fingers. So multiply, I get x to the 3 minus 6x squared plus 10x. So I'm done with this one, so I'm going to the next one. So minus 2x squared plus 12x minus 20 equal to 0. Okay, then I'm going to start to collect my like terms. So there's no like terms for x3, so let's leave it by itself. So I got a square term here. So minus 6 and minus 2 will give you minus 8. Again, same sign, you add the numbers together. And then I have this one and this one. So it would be plus 22. Again, same sign, you add the numbers together. Okay, and that's it. Okay. Okay, let's go to example 2. Okay, you got x to the 4 minus 12x minus 5 equal to 0. And you have a r1 equal to negative 1 plus 2i. Okay, so right away we know that r2 is going to be equal to negative 1 minus 2i. It's conjugate. Okay? So I'm going to use this to get my depressed equation. Okay, so again, you got x squared minus. So these two answers came from this equation over here, minus r1 plus r2 x plus r1 r2 equal to 0. Okay, so these two answers came from this equation. So x squared minus. So again, when you add the conjugate, this part plus 2i minus 2i will cancel out. So when you add, you will get negative 2, right? Negative 1 plus negative 1 give you negative 2. When you multiply, negative 1 times negative 1 is positive 1. Plus times minus is minus. 2 times 2 is 4. I times I is negative 1. So negative 4 times negative 1 become plus 4. Okay? And you simplify, so you got x squared plus 2x plus 5 equal to 0. So these two answers came from this part. So this is part of this. So when you factor these, so basically what it's saying is that x to the 4 minus 12x minus 5 equal to 0. This can break into two factors. You're going to have x squared plus 2x plus 5 and something else over here. Okay? So again, this came from these two. Again, just working backward. Okay, from here you get a conjugate answer. From these two answers, you work backward, you get this equation. So this answer came from here. Therefore, this can factor into two parts, okay? And so you have this part, and you have to figure out this part. Well, this times this will equal to that. So to figure out these, you have to divide. So use this divide by this. Now, we cannot use a synthetic division because this is the square, right? So we cannot use a synthetic division. So you have to use a long division. Okay, and so the x to the 4, x to the 3, x to the 2, x to the 1 and 0, right? So you can make sure you have two spaces over here for the 3 power and 2 power. Okay, so now we're going to divide. Okay, again, look at the first term, so I need to have x squared. So when I multiply, I get x to the 4 plus 2x to the 3 plus 5x squared. Draw the line. Okay, put parentheses, subtract. So 0 minus 2 will give me negative 2. 0 minus 5 will give me negative 5. Okay, and you drop the next one. Again, look at the first one, so I need to have a minus 2x. Again, all this must go down in order. Okay, so go and multiply. So minus 2x to the 3, minus 4x squared, minus 10x. Okay. Put parentheses, subtract. So this will give me negative x squared, and this will give me minus 2x, and drop that, give me minus 5. And so I need to get negative 1. And again, all this have to divide exactly because this is a factor of that. So everything has to come out exactly. If not, means you're doing something wrong. Okay, see that? So again, this has to be exactly. Okay, Okay, so once we get these, right? Once we divide, then we know what goes in here. Okay? And so we need to get answers from here. So there are two answers. So this goes in here. Okay? So this give me these two answers. Now I have to solve these. And this is not factorable, so you have to use quadratic equation, quadratic formula. So you got x squared minus 2x minus 1 equal to 0. So you got a equal to 1, b equal to negative 2, c equal to negative 1. So you got x equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay. So go and work it out. So this become positive 2 plus or minus square root of negative 2 squared is 4. Negative 4 times negative 1 is plus 4 over 2. So x equal to 2 plus or minus square root of 8 over 2. And again, you can go off to the side to simplify that. This is square root of 8 is 2 square root of 2. Okay? And dividing by 2. So you got x equal to 1 plus or minus square root of 2. Okay, so now we can put all the things together. So our answers are, from here, we're going to get negative 1 plus or minus 2i. Okay, so that's this 2. And this over here, you're going to get 1 plus or minus square root of 2. Okay, so these are two answers, and these are two answers, so there are 4 answers. Okay. Okay, so next one is the Descartes rule of sign. It kind of shows you what kind of possibility of the answers would be, and the best way to do that is let's go to example 3. It says this is the possibility for the nature of the roots. Positive, real, negative, real, and imaginary for the equation p of x equal to 0, where p of x is equal to x to the 5 plus x to the 4 minus 3x squared plus 4x plus 6. Okay, so you're going to make a table with 3 columns. So positive answer, negative answers, and imaginary. Okay? So Descartes rule of sign says that you want to see how many times you change sign. So this is positive x. So this would be how many answers you can have for here. Okay? So this is positive. So positive to positive, it does not change. From positive to negative, it changes. So check a mark. Right? So from negative to positive, again, it changes again. So whenever it changes, you put a check mark. Okay? When over here, it didn't change. So when it changes sign twice, that means you're going to have the maximum of 2 positive answers. Okay? So figure that out. Now, to find the negative, you have to use p of negative x. Okay? P of negative x means you make all the x become negative. Okay? So p of negative x will equal to, now notice the odd exponent will change sign. So the negative will become, the odd exponent will give you negative. So it would be negative x to the 5. Negative to even power will become positive. So notice when it's even, the sign stays. If it's odd, it will change. Okay? So this one, again, it stays. And this one, minus 4x plus 6. So again, first you have to get the p of negative x. Then again, you figure out how many times it changed the sign. So from negative to positive, it changed. From positive to negative, it changed again. From negative to negative, doesn't change. Negative to positive, it changed. Okay? So you're going to get maximum of 3. Okay? So what I'm saying is that if you solve this equation, if you set it equal to 0 and solve the equation, the most positive answer you're going to get is 2 positive and 3 negative. Now, this is a 5th power, so you're going to get total of 5 answers. So if you get 2 and 3 here, you're going to get 0 here because the total has to equal to 5. Okay? So what it's saying is that this is your maximum. Okay? So your maximum will have maximum of 2 positive and maximum of 3 negative. Okay? Then after that, you have to these other possibilities. Okay? And the possibility will be go down by 2s. Okay? Because you have to exchange, because imagine you must have a conjugate. Okay? So you have to go down by 2s. So if you exchange 2 of the negative answers into conjugates, so you're going to get 2, 1, 2. Again, this is your maximum, so you cannot go up before this, but you can go down. So that's one possibility. Another possibility is when you go down from here. So instead of go down negative, you use a go down on a positive. So you're going to get 0, 3, 2. Right? It can always add up equal to 5. So in other words, over here you exchange the one pair of negative answers to get a conjugate answers, a conjugate imaginary. And there's another possibility is you exchange 2 of these positive answers for that. You also can have another possibility. You can exchange both. So you can go down. So first you let this go down. Next you let this go down. Next you let both of them go down. So you go 0, 1, okay, and it will be a 4. Again, this has to be always even numbers, okay, because you have to have a conjugate to get rid of the i's. Notice there's no I over here. So therefore, you need to get pairs. So this always has to be even in order to get the integers. Okay. So these are your possibility of your answers. So that means you will never ever get 3 positive answers. And this is going to become important later on, okay, as you start to do trial and error. Okay, that way it kind of give you a clue of what to try and what you don't need to try.